December 7, 1941. Pearl Harbor burns. America enters World War II. The Pacific Fleet lies shattered in the harbor. The only offensive weapon available to strike back at Japan is the submarine force. American submarines immediately deployed to hunt Japanese shipping, their primary weapon, the Mark 14 torpedo, the Navy's most advanced weapon, self-propelled, magnetic detonator that exploded beneath enemy ships, breaking their keels, faster and more sophisticated than anything the enemy had. Or so the Navy claimed. Lieutenant Commander Lawson Red Ramage watched through his periscope as a perfect torpedo shot streaked toward a Japanese transport. Range 800 yards, angle 90 degrees. A perfect broadside shot, the kind submariners dream about. The torpedo ran straight and true, passed directly beneath the Japanese ship. Nothing happened. No explosion, no damage. The transport sailed on, unaware it had just been attacked. Ramage fired again. Same result. The torpedo ran under the target. No explosion. He fired a third time. This one hit the ship's hull directly and bounced off without detonating. 3 torpedoes, 3 failures. 1 furious submarine commander. This wasn't an isolated incident. This was happening to every American submarine in the Pacific. Torpedoes that didn't explode, torpedoes that ran too deep, torpedoes that hit targets and failed to detonate, torpedoes that exploded prematurely, alerting the enemy. For 2 years, American submarines fought with defective weapons. Submariners risked their lives to get perfect shots, only to watch torpedoes fail again and again. The Bureau of Ordnance, responsible for torpedo development, insisted the weapon was perfect. Any failures were submarine crew incompetence. It took a mutiny by submarine commanders, unauthorized field testing, and finally, one simple change to turn the Mark 14 from a liability into the most lethal torpedo of World War II. This is the story of America's torpedo scandal, how bureaucratic arrogance cost lives and prolonged the war, and how one modification transformed failure into guaranteed kill shots. The Mark 14 designed to be perfect. The Mark 14 torpedo was supposed to be revolutionary. Developed in the 1930s, it incorporated the most advanced technology available. Magnetic influence detonator, the Mark 6 exploder. Instead of hitting the ship directly, the torpedo would run beneath the target. A magnetic sensor would detect the ship's metal hull passing overhead and detonate the warhead underneath the keel. This would break the ship's back, 1 shot, 1 kill. Deeper running depth. Since it exploded beneath ships rather than hitting them, the torpedo ran at greater depth, harder for enemy lookouts to spot. Longer range. The Mark 14 could travel over 4,000 yards, farther than previous torpedoes. Faster speed, 46 knots, fast enough to catch most merchant ships. The Mark 14 was supposed to be the perfect submarine weapon, in theory. The problem was that in the 1930s, torpedoes were incredibly expensive to test. Each Mark 14 cost approximately $10,000, equivalent to about $200,000 today. The Bureau of Ordnance decided they couldn't afford comprehensive testing. They tested the torpedo's propulsion system. They tested the depth control. They tested the magnetic detonator under carefully controlled conditions. But they never tested the complete weapon system under actual combat conditions. They never fired live warheads at actual ships. They never tested the magnetic detonator in varying magnetic fields like those found across the Pacific. They assumed everything would work perfectly in combat. It was a catastrophic assumption. December 1941, the failures begin. Immediately after Pearl Harbor, American submarines went on the offensive. Their mission? Sink Japanese shipping, cut off supplies to Japan's military, strangle their economy. The submarines performed brilliantly. Captains like Dudley Marsh Morton, Dick O'Kane and Sam Dealey were aggressive, skilled, and fearless. They positioned their submarines perfectly. Close to point-blank range, fired spreads of torpedoes at perfect angles, and watched in disbelief as the torpedoes failed. Problem 1. Premature detonation. Torpedoes exploded before reaching the target, sometimes hundreds of yards away. This alerted the enemy to the submarine's presence and wasted torpedoes. Problem 2. Dud hits. Torpedoes hit enemy ships directly and didn't explode. Submariners could hear the impact through their hulls, no detonation. Problem 3. Running too deep. Torpedoes set to run at 10 feet depth actually ran at 25 feet. They passed harmlessly beneath targets. Problem 4. Erratic running. Torpedoes veered off course, ran in circles, or behaved unpredictably. Submarine commanders reported these failures to their superiors. The Bureau of Ordnance response was consistent and infuriating. The torpedo is perfect. The failures are your fault. Submarine crews were told they were. Setting depth incorrectly. Calculating firing angles wrong. Not maintaining torpedoes properly. Suffering from buck fever, combat stress causing mistakes. This was insulting and dangerous. Submarine commanders were highly trained professionals. They knew how to calculate firing solutions. They knew how to maintain equipment. They were risking their lives to attack enemy ships. And the Navy was telling them they were incompetent. The cover-up, Bureau of Ordnance denial. The Bureau of Ordnance had invested years and millions of dollars developing the Mark 14. The magnetic exploder was supposed to be revolutionary. A war-winning secret weapon. Admitting the torpedo was defective meant admitting the Bureau had failed, that they'd deployed a weapon without proper testing, that they'd wasted taxpayer money and time. Bureaucratically, this was unacceptable. So the Bureau doubled down. They insisted the Mark 14 worked perfectly. They blamed submarine crews for every failure. When submarine commanders provided detailed reports of torpedo failures, the Bureau responded with explanations. Premature detonations? The magnetic detonator was too sensitive. Submarine commanders should disable it and use contact detonation only. Torpedoes running deep? Incorrect depth settings by submarine crews. Follow procedures better. Dud hits? Insufficient evidence. Probably the torpedoes missed and crews mistakenly thought they hit. This gaslighting infuriated submarine commanders. They knew what they'd seen. Perfect shots, direct hits, no explosions. Captain Dudley Morton of USS Wahoo became so frustrated, he started conducting unauthorized tests. He'd fired torpedoes at shallow depth into beaches and retrieved them to examine the damage. He discovered the torpedoes were consistently running 11 feet deeper than set. He reported this to the Bureau of Ordnance. They dismissed his findings, unauthorized testing, not conducted under controlled conditions. Results invalid. The bureaucratic denial continued for over a year. While American submarines fought with defective weapons, the Bureau protected its reputation. Problem 1 discovered: the depth control. By mid-1942, submarine commanders had compiled overwhelming evidence that torpedoes ran deeper than set. They'd fired torpedoes at targets in known shallow water too shallow for the torpedoes to run at their supposedly set depth. The torpedoes hit the bottom. This proved they were running deeper than indicated. Finally, in June 1942, the Bureau of Ordnance authorized proper testing. They discovered the problem immediately. The depth control mechanism didn't account for the torpedo's actual running conditions. The Mark 14 depth was calibrated based on test runs in fresh water at the Newport Torpedo Testing Facility. But combat operations were in salt water. Salt water is denser than fresh water. The torpedo's behavior was different. Additionally, when the torpedo motor fired and the weapon accelerated to 46 knots, Water pressure increased on the depth control mechanism. This forced the torpedo to run deeper. The result, a torpedo set to run at 10 feet actually ran at 25 to 30 feet. This explained why torpedoes passed harmlessly beneath targets, why magnetic detonators didn't explode. The torpedo was too far below the target to detect its magnetic field. The fix was simple: recalibrate the depth settings. Set the torpedo to run at negative depth to compensate for the errors. By August 1942, this problem was identified and corrected. Submarine commanders were relieved. Finally, the torpedoes would work. They didn't. The problems continued. Problem 2, the magnetic exploder. Even with corrected depth settings, torpedoes still failed. They'd run at proper depth, pass beneath targets, and not explode. The problem was the Mark VI magnetic influence exploder. The theory was sound: detect the target's magnetic field and detonate beneath the keel. But the execution was fatally flawed. Earth's magnetic field varies. The Mark VI was calibrated for magnetic conditions near Newport, Rhode Island, where it was tested. The Pacific Ocean has different magnetic field characteristics. The detonator's sensitivity was wrong for actual combat conditions. Ships' magnetic fields vary. Different ships had different magnetic signatures depending on their steel composition, cargo, and orientation. The Mark VI couldn't reliably distinguish between conditions that should trigger detonation and those that shouldn't. Temperature affects electronics. The Mark VI's electronic components behave differently in tropical Pacific waters than in temperate Newport waters. The result? The magnetic detonator was unreliable. Sometimes it detonated prematurely. Sometimes it didn't detonate at all. Sometimes it worked perfectly. Submarine commanders couldn't trust it. By mid-1942, most submarine captains were deactivating the magnetic exploder entirely. They relied on contact detonation only. The torpedo had to physically hit the target to explode. This reduced the Mark XIV's effectiveness. Instead of breaking a ship's keel with an underwater explosion, the torpedo had to hit the hull and hope the contact detonator worked. Which led to the third problem. Problem 3, the contact detonator. With the magnetic exploder deactivated, American submarines relied on the Mark XIV's contact detonator, a mechanical device that exploded the warhead when the torpedo hit a target. Submarine crews discovered this was also defective. Perfect shots at 90-degree angles, broadside hits, resulted in duds. The torpedo would hit the target's hull. Submariners could hear the impact, no explosion. The Bureau of Ordnance insisted this was impossible. The contact detonator had been tested. It worked perfectly. But submarine commanders kept reporting the same problem: direct hits, no explosions. Finally, in mid-1943, submarine commanders conducted unauthorized field testing. They fired torpedoes at cliffs at varying angles. At shallow angles, 30 to 45 degrees, the detonator worked. At perpendicular angles, 90 degrees, the detonator failed. This made no sense. Why would a perpendicular hit, the ideal shot, cause failure? The answer revealed a design flaw so fundamental it was almost unbelievable. The discovery: inertia kills. The Mark XIV contact detonator used a simple mechanical firing pin. When the torpedo hit the target, inertia drove the firing pin forward into a primer, which detonated the main warhead. This worked perfectly in testing, when torpedoes were fired at oblique angles at slow-moving or stationary targets. But in combat, when torpedoes hit hardened steel hulls at 90-degree angles at 46 knots, something different happened. The impact was so sudden and violent that the firing pin's inertia couldn't overcome the deceleration. The torpedo stopped instantly. The firing pin, secured by mechanical components, couldn't move forward fast enough to strike the primer. The harder the impact, the less likely detonation became. This was backwards. Perfect shots, 90-degree hits at high speed were the least likely to detonate. Glancing blows at shallow angles were more likely to explode. Submarine commanders were being penalized for making perfect shots. The fix required a complete redesign of the contact detonator. This would take time measured in months while submarines continued fighting with defective weapons. The interim solution: fire more torpedoes. While the Bureau of Ordnance worked on fixing the contact detonator, submarine commanders developed workarounds. Fire spreads of torpedoes. Instead of firing one torpedo, fire 4 or 5. Statistical probability meant at least one might work. Aim for oblique angles. Deliberately set up shots at 45-degree angles instead of perfect 90-degree shots. The contact detonator was more reliable at oblique impacts. Target thinner-hulled ships. Merchant ships had thinner hulls than warships. The contact detonator worked better against softer targets. Use end-of-run explosions. Some submarines set torpedoes to explode automatically if they missed and reached the end of their run. This at least created confusion. These workarounds helped, but they meant using more torpedoes per target. Submarines carried limited torpedo loads, typically 24 torpedoes. If you needed to fire 4 torpedoes per target instead of 1, your combat effectiveness was reduced by 75%. And submarine resupply in the Pacific was difficult and time-consuming. Every wasted torpedo meant fewer targets engaged per patrol. The torpedo failures weren't just frustrating, they were strategically costly. September 1943, the fix. In September 1943, 21 months after the war began, the Bureau of Ordnance finally deployed a redesigned contact detonator. The new design was embarrassingly simple. Instead of relying on inertia to drive a firing pin forward, the new detonator used a crush mechanism. When the torpedo hit a target, the impact crushed a thin metal disc. This mechanical crushing, not inertia, triggered the detonation. The harder the impact, the more reliably it worked. 90-degree hits at high speed became the most likely to detonate instead of the least likely. This was the one change that transformed the Mark 14 from a defective weapon into a guaranteed kill shot. The results were immediate and dramatic. The transformation before and after. The statistics tell the story. January 1942 to August 1943, defective torpedoes. American submarines fired approximately 1,400 torpedoes. Confirmed sinks approximately 150 ships. Hit rate roughly 10 to 15%. Torpedoes per kill 9. 10 torpedoes. Many submarine commanders reported expending entire torpedo loads. 24 torpedoes to sink 2 or 3 ships. Some patrols returned without sinking anything, despite multiple perfect shots. September 1943 to August 1945. Fixed torpedoes. American submarines fired approximately 14,000 torpedoes. Confirmed sinks, over 1,200 ships. Hit rate, roughly 40 to 50%, torpedoes per kill, 2-3 torpedoes. The improvement was staggering. The same submarines, same commanders, same crews. But with functioning torpedoes, their effectiveness increased by 300 to 400%. Individual submarine performance improved dramatically. USS Tang, under Commander Dick O'Kane, sank 24 Japanese ships in 5 patrols using the improved Mark 14. Vess Flasher sank over 100,000 tons of Japanese shipping, more than any other submarine. USS Barb, under Commander Eugene Flakey, became legendary for aggressive attacks using the reliable torpedoes. The American submarine campaign that had been frustratingly ineffective for 2 years suddenly became devastatingly effective. The impact: strangling Japan. With functioning torpedoes, American submarines accomplished their strategic mission, destroying Japan's merchant fleet and cutting off supplies. By war's end, American submarines had sunk 1,392 Japanese merchant ships, 5.3 million tons, destroyed 201 Japanese warships, including 1 battleship and 8 aircraft carriers, accounted for 55% of all Japanese shipping losses, essentially eliminated Japan's ability to import oil, food, and raw materials. This underwater blockade strangled Japan's economy and military. By 1945, Japan couldn't fuel its aircraft, supply its armies, or feed its population. The submarine campaign was arguably more strategically important than any surface naval battle. But this success came 2 years later than it should have. If the Mark 14 had been properly tested and deployed in working condition in December 1941, how different would the Pacific War have been? Japanese expansion in 1942 depended on seaborne supply lines. Effective submarine warfare might have disrupted those operations earlier. The battles of Coral Sea, Midway, and Guadalcanal might have been easier for American forces if Japanese logistics were already compromised. The war might have ended months earlier, saving thousands of American lives. Instead, bureaucratic incompetence and arrogance forced submarine crews to fight for 2 years with defective weapons. The human cost. The torpedo scandal wasn't just about statistics and strategic effects. It was about submarine crews who risked everything to make perfect attacks and watch those attacks fail. Submarine warfare was already the most dangerous job in the U.S. military. Submarines operated alone deep in enemy-controlled waters with no support if things went wrong. The U.S. submarine force represented 1.6% of the Navy, but suffered 22% of all Navy casualties. Of 288 submarines that deployed, 52 were lost. 374 officers and 3,131 enlisted men killed, about 22% of submariners who served. Every time a torpedo failed, the submarine's position was compromised. Enemy ships knew they'd been attacked. They'd call for escorts, launch depth charge attacks, hunt the submarine. A working torpedo meant fire, sink the target, escape while the enemy is confused. A defective torpedo meant fire, watch it fail, endure depth charge attacks while trying to escape. How many submariners died because defective torpedoes allowed enemy escorts to counterattack? How many submarines were lost because they had to expose themselves repeatedly to sink targets that should have gone down with one shot? We'll never know exact numbers, but every submarine crew that fought from December 1941 to September 1943 did so at increased risk because of defective weapons. And the Bureau of Ordnance spent those 2 years insisting the weapon was perfect and the crews were incompetent. The accountability that never came. After the war, there should have been investigations, courts-martial, accountability for the bureaucratic failure that cost lives and prolonged the war. There wasn't. The Bureau of Ordnance officers responsible for the Mark 14's development retired quietly. Some received commendations for eventually fixing the problems. No one was fired for deploying defective weapons. No one was court-martialed for ignoring submarine commanders' reports. No one was held accountable for the institutional arrogance that dismissed field reports in favor of theoretical testing. The official Navy position became, the Mark 14 had some initial problems that were identified and corrected through normal development processes. This sanitized version erased the truth. The Bureau of Ordnance deployed an inadequately tested weapon. When failures were reported, they blamed the users instead of investigating the reports. They resisted fixing problems for 2 years. Only when submarine commanders conducted unauthorized testing and threatened mutiny did the Bureau finally acknowledge and fix the defects. The submarine commanders who fought against both the enemy and their own bureaucracy received no special recognition for their persistence. They were expected to follow orders and not complain. The crews who died while their weapons failed received no special acknowledgement. The scandal was quietly buried in classified reports and technical documents. The broader pattern. The Mark 14 torpedo scandal wasn't unique. It represented a pattern in military procurement and bureaucracy. Inadequate testing due to cost concerns. The Bureau of Ordnance didn't test the Mark 14 under actual combat conditions because live fire tests were expensive. They relied on theoretical models and limited testing. Refusal to accept field reports. When operational commanders reported problems, the bureaucracy dismissed those reports rather than investigating them. Protecting institutional reputation over mission effectiveness. Admitting the Mark 14 was defective meant admitting the Bureau had failed. Bureaucratically, this was unacceptable, even if it cost lives. Blaming users instead of fixing systems. The Bureau blamed submarine crews for failures instead of examining the weapon system. This pattern appeared in other military failures. The M16 rifle in Vietnam had similar problems. Inadequate testing, field reports dismissed. Users blamed for system failures. The Bradley fighting vehicle development involved bureaucratic resistance to addressing fundamental design flaws. The F-35 program has faced similar issues with testing shortcuts and dismissing operational concerns. The lesson? Bureaucratic self-protection often conflicts with military effectiveness. Without accountability, the pattern repeats. The heroes, submarine commanders who wouldn't quit. Despite fighting with defective weapons and being blamed for failures that weren't their fault, American submarine commanders persisted. Dudley "Mush" Morton conducted unauthorized testing and kept detailed records of torpedo failures. His persistence helped force the Bureau to investigate. Dick O'Kane documented every torpedo failure and provided technical analysis that helped identify problems. After the torpedo was fixed, he became the most successful American submarine commander. Sam Dealey of USS Harder developed tactics to work around torpedo defects and still achieved remarkable success. Eugene Fluckey of USS Barb continued aggressive attacks despite weapon failures and became legendary once the torpedoes were fixed. These commanders and dozens of others refused to accept that the failures were their fault. They kept fighting, kept documenting problems, kept pushing the bureaucracy. They were proven right, but it took 2 years. The one change that mattered. So what was the one change that turned the Mark 14 into a guaranteed kill shot? It wasn't fancy technology, it wasn't a revolutionary innovation. It was embarrassingly simple. Replace the inertia-based contact detonator with a crush-based detonator. That's it. A mechanical change that cost maybe a few $100s per torpedo. This change meant that perfect shots, 90-degree hits at high speed, became the most reliable instead of the least reliable. Suddenly, submarine commanders' training and skill mattered. Good shots produced kills. The weapon did what it was supposed to do. The transformation was immediate. Submarine effectiveness increased by 300 to 400%. The same crews, same tactics, but functional weapons. This is the lesson. Even the most sophisticated weapon system is useless if basic components don't work. The Mark 14 had advanced magnetic detonators, sophisticated depth control, and long-range capability. None of that mattered if the contact detonator didn't explode when hitting a target. Getting the basics right matters more than advanced features. The legacy. The Mark 14 torpedo scandal left several legacies. Improved testing protocols. Modern weapons undergo more realistic operational testing before deployment. Greater respect for field reports. Operational commanders' feedback is taken more seriously than in 1942. Faster problem recognition. When weapons fail in the field, there are now systems to investigate and address problems quickly. But the most important legacy is the story itself, a reminder that Bureaucratic arrogance can be as dangerous as the enemy action. User reports should be taken seriously, not dismissed. Weapons must be tested under actual combat conditions, not just theoretical models. Accountability matters. When failures occur, those responsible should face consequences. The submarine crews who fought for 2 years with defective torpedoes deserve to be remembered not just for their eventual success, but for their persistence in the face of bureaucratic betrayal. Conclusion: the simple fix. December 1941. American submarines deployed with the perfect Mark 14 torpedo. It failed catastrophically. Didn't explode, ran too deep, hit targets and bounced off. The Bureau of Ordnance insisted the weapon was flawless, blamed submarine crews for incompetence. For 2 years, American submariners fought with one hand tied behind their backs, perfect shots wasted, lives risked for nothing, a strategic advantage squandered. September 1943, one simple change. Replace the inertia-based contact detonator with a crush-based mechanism. Suddenly, the Mark 14 became the weapon it should have been from the start. Reliable, deadly, effective. American submarines transformed from frustrated hunters into devastating killers. They strangled Japan's merchant fleet, cut off supplies, helped win the war. But that success came 2 years late. 2 years of unnecessary risk. 2 years of wasted opportunities. 2 years because bureaucrats cared more about protecting their reputations than fixing their mistakes. The lesson is simple. Test your weapons under real conditions. Listen to the people using them in combat. Fix problems immediately, not after 2 years of denial. And never, ever blame the users when the system fails. That one simple change from inertia detonator to crush detonator turned American torpedoes into guaranteed kill shots. It just took 21 months of failure, bureaucratic stubbornness and submariner persistence to make it happen. The submariners who fought those 2 years with defective weapons deserve better. They eventually got functioning torpedoes. They never got the apology they were owed.